Right, everybody. I'm just going to do a quick video here on gas laws because I was told this one was coming up and a few people were asking me about this. So I'll just do a quick video. These are some of the questions I have, the greatest hits, you can call them, and we'll see if you might get a few of these in the exam. So I'll go straight into it here then. Right. Now the first one here then is get my yeah, okay, yeah, there's the pen there. Yeah, so you've got now just to highlight a few things here then. 100 kilopascals, you're going to have, that's pressure, you're going to have to change that to 100 multiplied by 10 to the power of 3, okay, because of the kilo. And then you've got over here 20 degrees Celsius. That will have to be changed into Kelvin, so you'd add 273, okay, 273. So you would get 20 there and add 273 and gives you 293 Kelvin. Okay, that's the change you have to make there, and everything else is okay then. And you're looking for the number of moles. So hopefully you can see that that's the formula you have to use, that one there. And you'd have that from chemistry. That's the universal gas law, isn't it? That one there, because it's got the R in there. N is the number of moles. Rearrange the formula, sub everything in, okay? The P is 100 by 10 to the 3. Volume is 0.1 meters cubed. Or that's the universal gas constant. And there's the temperature amended to give you the temperature in Kelvin, 293. So then I put all that into the calculator. Now you can check this. Yeah, make it a little bit bigger there. So, and then I got, when I did all that out, I got 4.1. Now, 4.1 moles. Okay, that's a bit too heavy there now. That is back to that one there. Fine. On to the next one then. Where am I? Down here. Okay. Now, the balloon in question 19 rises to a height where the pressure of the temperature of the balloon. Okay, so there's a change here then. Yeah, 30 kilopascals. You've got a new pressure, P2, and new temperature, T2, and you have to get the new volume. Yeah, so you're looking for V2. V2 is what you're looking for here. This is the new volume, okay? So then I just rearrange the formula there, and I can say that V2 then is going to be equal to P1 V1, and that T2 down there, the T2 here, that's going to go up there like that, over T1 is already there, and P2 comes down to join it there, and there you have it there. And you sub everything in then, and your P1 then was 100 by 10 to the power of 3, multiplied by the original volume is 0.1 of a meter cubed. And the new temperature then, well, the new temperature there is minus 30 degrees. So that's going to be 273 minus 30. That's going to give you 243 Kelvin. Line there. T1 then was the original temperature, that was 293. And P2, the new pressure, is 30 kilopascals. 30 multiplied by 10 to the power of 3. Again, I did it out earlier. Yes, I did all this one out, and I got there, you check there now on your calculator, 276, and it's volume. So it's meters cubed. So it's this one here, B. Okay, very good. And then on to the next one then, the kinetic energy of a gas. Well, there's a formula for that there now, and it's KE is equal to 3 over 2 KT. Now, yeah, kinetic energy, that's what that is there, KE. And this K over here is Boltzmann's constant, and the T here is temperature in Kelvin. So there you go. So the energy then, it's highlighted there, the energy is directly proportional to temperature on the Kelvin scale. So that's the answer there. And the next one then is, where are we? Down here. Oh, again, now the temperature remains constant, so it's the same formula as previously used. You see, there would have been a T1 here and a T2 there. But they would be, because they're equal, they would be cancelling each other out anyway, because they're both the same value. So I didn't even include them there in that. So that's just that part of the formula being used. And we're looking for V2, the new volume. So rearrange P1, V1, the P2 here. That P2 is going to go over and under. And there is there underneath there. Okay. And sub everything in then. Pressure 10 to the power 5. Well, 10 to the power 5 pascals. And volume 2. And the second pressure here is 8 multiplied by 10 to the power 5. Now, what happens? Cancel, cancel. 2 over 8 is a quarter, which is, as you know, 0.25. It's volume, so it's meters cubed. So where are we? Well, let's say it's marked out there already. Okay. Now on to the next one. Kind of an older question there, but these questions are very popular in physics. In physics exams, this one here now. I mean, you've got the initial volume is V0, and I'm using P sub 0 as the initial pressure, and then I'm using the new one then as the new pressure then is just P, and the new volume is just V because they gave V there, so I'm using a PV here. So instead of using P1 V1 equals P2 V2, I'm just using that. So and so what do we do then? Now the pressure is doubled. The pressure doubles. Okay, so we've got should be equal to 2 times P0 because it doubles. V stays the same. Now, straight away, then you can cancel. So that's gone with that. And what are we looking for? The ratio we're looking for, highlighted here. That's the ratio we're looking for. V over V0. That means keep the V here, keep that V, and move the V0 over and under. And what was on the other side? A 1 understood there. And the 2 goes over and under. Maybe I could have just went like that there as well. V0 is equal to 2 times V. Yes, that's good to write that down. And then we can get the ratio then of V is to V0, which is going to be 1 over 2. So the answer there is C. Okay. So yeah. So if the pressure is doubled, the volume is halved. That is Boyle's law, and you do need to know what Boyle's law is, okay? So you better learn that off. Okay, at constant temperature for a fixed mass of gas, the pressure varies inversely with the volume. You better know that because that could come up as a definition. So you would be expected to know that. And you're all doing chemistry anyway, lads. So I mean that this part of the course should be fairly familiar, you know, not too intimidating anyway. And the last one I have here then is this one here then. You see you've got your, okay, Grant, that's good. 0.02, that's volume, that's good. There's your pressure. You'll have to multiply that by 10 to the power 3 again. Now, 17 degrees Celsius, that will have to be changed into Kelvin. So watch that. And you've got Boltzmann's constant and the number of molecules. Well, then it's clearly that formula there. PV is equal to NKT, capital N, the number of molecules, and K is Boltzmann's constant. So the other previous one was the universal gas law, which was, can I squeeze it in over here? PV is equal to N or T, right? That's the one you'd use in chemistry a lot, because chemistry is, you know, concerned about the number of moles more than the number of molecules. But this one is more popular, I'd say, in physics because you're looking at the number of molecules. Anyway, so that's what we're asked here. N is equal to, so keep the N, the KT goes over and under, sub everything in, and that's what I got, 5.5 by 10 to the power 24. There it is there, B again, okay? So hopefully now that's all I've got, 5 or 6 questions, and you won't get any more than that on the exam anyway. And hopefully you got a few hits there. And so I'll just stop recording there now and try to upload that one there. So where am I? Right, talk to you later.